So I was discussing about some method of our concern regarding like Colin method. Uh, in order to see whether your model is unstable or not, you need to see the condition number that is provided under your second table. If it is more than 10, it is an indication of instability of your model. So remove the variable with the highest VIF and rerun the Colin command on the remaining variables again in order to make it stable. For example, if we see that the highest VIF is 3.97 with institutional ownership. So if we run this command without institutional ownership, so let's see what will happen. This one, need to remove institutional ownership from here. I need to rerun it again, and I need to see the condition number. The condition number is still greater than 40, greater than 10. Now I need to see which of these have the highest number of VIF. So VIF, highest VIF is with firm size. I need to exclude firm size from here, like this one, firm size. Need to rerun it again to see what will happen. It drops to 26, and I need to see which one still at the highest VIF. It is, sir, you said that VIF is less than 5 or no MC, and why we check the column and after that our model is not good. Basically, if you see the multicollinearity only, if you see the multicollinearity only, then VIF procedure is okay. But if you want to correct the stability of your model, then you need to consider the Colin procedure. So Colin is basically the advanced procedure to make your model stable. So we need to consider with which combination of independent variable your model becomes stable. So that's why I am using this procedure. It is basically not required, but in order to make my model stable for estimation purpose, I need to remove the values with highest VIF and rerun the procedure again and again. So let's see what will happen when the index number drops to 10. So here the highest VIF is basically 1.33, that is PR ownership. So let's remove PR ownership from here, like this one. Just remove it. Now see what will happen. The condition number is 20 now. Now the next highest VIF is node, NOD. So let's remove node from this and see what will happen. Now the index number is 17. The next highest number in terms of VIF is 1.04, which is for period. So let's remove it in order to make your model stable. Period. It is 15 now. We can still have VIF values, but our model is somewhat stable. The remaining VIF values are same, so we cannot consider which one should we remove now, or which one we should retain now. So we can consider this combination of variable for our regression model. For example, if I need to reg our model now based on Tobin's Q as a DV and this combination of variable as a IV. So we can check how much our model is stable in terms of estimation. You can check the R square has decreased, model is significant, and majority of variables are here. These are significant. only one variable S growth is not significant. So S growth has highest value in terms of tolerance, 9949. So what will happen if we remove S growth from colon command? S growth from here. Now this is the remaining combination. The index also decreased and the remaining combination is tolerance. So we can run the regression command now. Rec tolerance Q with this combination of IVs. There are only 4 variables remaining, so we cannot further decrease it. R square is still lower, but your combination of variables are basically significant with this combination. So, colon procedure basically provides the stability of your model. It is not necessary. It is up to you whether you want a stable model or not. Polling procedure is only used when you want to consider the stability of your model. But if you don't want to consider the stability, you can stick to VIF only. If the VIF is less than 10, you can retain your variable. Otherwise, you can drop a particular variable with the highest VIF value. So what are the remedies for removing the multicollinearity? What will happen if you remove the multicollinearity uh, for the purpose of multicollinearity? If you remove a particular variable, what will happen? So Vakar is asking, it means through this we can make our model good. No, this is not necessary. Model goodness is a separate thing. You can make your model good uh, by applying the assumptions, by testing the assumptions, and by applying the transformation. This is the technique that you can apply only for the stability of your model, whether your model is stable or not. So I do not recommend personally the Collin procedure, because this procedure is basically introduced recently. Uh, the only reason that they provide in terms of stata, that it will consider the stability of the model. So I would not recommend. I will consider that you should test the assumptions. If the assumptions are violated, you can apply the transformation in order to make your model good. So don't worry, I will let you know how to make your model good. So there are different types of multicollinearity and what decision we can take. If your multicollinearity is mild, mild means that it should be less than 10. If the multicollinearity, if the VIF is less than 10, then it is called mild multicollinearity. In that case, what is the decision? In case of mild multicollinearity, you don't need to do anything. You don't need to drop any of your variables. If we see previously, if we see the VIF value in our previous procedure, like you can see here, yes, this one. Here, these are indicating the mild multicollinearity because the VIF values are less than 10. So in that case, we don't need to do anything. So the decision is that you don't need to do anything if you have mild multicollinearity. But if you have perfect multicollinearity, then what to do? Perfect multicollinearity is when your VIF value is greater than 10. So in case if your VIF value is greater than 10, then what you need to do, try to increase the sample size. That is the best thing that you can do. If it is possible for you to increase the sample size, try to increase the sample size. It will control the multicollinearity issue. If perfect multicollinearity is there and you only require forecasting or prediction, if you do not want to interpret your beta coefficients, like I have interpreted this table. This is basically the standardized interpretation I have done. I have interpreted how much value of the beta was and what was the p value here. This is the interpretation. In case of prediction, you don't need to interpret the model. You just need to tell that there is a positive impact. It may increase your dependent variable. It may decrease your dependent variable. For example, financial ownership may increase your ROA. NOD may increase your ROA. Firm size may decrease your ROA. If you want to predict only the direction of your independent variable, then you do not need to do anything. But if you want to make interpretation like this, that you want to consider the p value, and you want to consider how this beta coefficient value along with significance may imply your dependent variable, then you need to consider the other remedial measure, like try to increase the sample size. So if only forecasting is there, if only prediction is there regarding the direction, regarding the positive or negative impact of your variable, then you don't need to do anything. In case of perfect multicollinearity, if sample size cannot be increased due to time and cost, then you should not do anything, because there is a constraint that you cannot increase the sample size. If perfect multicollinearity is there, and theory permits to estimate uh, your coefficients, then you also do nothing. If your theory allows to consider a particular relationship, you can consider that particular relationship in that case, and you don't need to do anything. But you need to drop one of the independent variable that is causing multicollinearity. In case of perfect multicollinearity, if multicollinearity is found between two independent variables, then you try to drop the less significant. You need to see which one is more significant and which one is less significant. For example, this is basically our regression results. So I need to see which variable is more significant and which one is less significant. For example, let's suppose uh, this is a variable which is not significant, and this is another variable which is significant. So you need to see which one is more significant. So node is more significant, and I have found that there is a multi-correlation, or there is a multi-collinearity between these two variables. So I can drop this one with less significance value. If there is a multicollinearity between node and parrot, I should drop the parrot because it is less significant while the other one is more significant. So drop the one with less significant, drop the one with larger VIF. Also compare how much VIF uh, these two are showing. If parrot is showing the larger VIF, drop this one. If this one is showing the larger VIF, drop this one. So you need to see which one is showing the larger VIF value. So do not drop the variable if the theory makes this variable compulsory to include in the model. So always remember, if theory has made a particular model compulsory for you to analyze, so do not drop that model because theory allows that model. So in case of perfect multicollinearity, what other things you can do? You can transpose your variable, like if there are some variables which are relevant to each other, like import and export, you can transform them, you can add them to make them combine. Like I have told you that in the morning some lady called me and she asked me that she is facing a multicollinearity issue in her data, and I find out that she was using ROA and ROE, both variable in her data set. And I found a multicollinearity between those two variables. So I suggested her to combine them in the form of a combined index. value. So you can combine some variables which are relevant to each other. You can also make them in a net version of a variable. Like you can minus the export from import to make it net export. You can take the log values, you can take the first difference, you can divide the variable by appropriate measure. There are a lot of transformation procedure. I will let you know how to transform your particular variable if it is showing, if it is a very necessary variable, you can transform that variable. Then in case of perfect multicollinearity, if you are using time series data or you are using cross sectional data, you can convert into a panel. If you are using time series data, you should convert it into panel. And if you are using cross sectional data, you should also convert it into the panel. So in case of panel data, the multicollinearity issue is resolved automatically. So someone asked me, what is the real benefit of using the panel data? So real benefit of using panel data is that it will control the multicollinearity issue. So the last one is in case of multicollinearity, what we need to do, we should consider the factor analysis. We should use rigid regression. There are a lot of options, but I normally use the transformation process to make my variable transform. So this is today's part. Tomorrow we will discuss the assumption number 5 and 6. Those are two last assumption, and then I will let you know how to transform your data and how to consider the other aspects like model specification, the missing value analysis, the missing variable analysis, how to apply them. So for today, it is the complete the session. So if you have any question, you may ask. Yes, Adnan Afzal, do you have any question?
No, dear. Thank you so much.
All right. So let's get some sort of time. Thank you very much for joining. Let's meet tomorrow. Allah Hafiz.